All right, today we're going to be going over lesson 3 in chapter 1 on distance and midpoints. You are going to be given the distance formula and the midpoint formula, which are both super important for pretty much the rest of geometry. We use them all the time, so make sure you write them down somewhere and you keep track of those because you will be using them again. All right, so for distance and midpoint, our essential question is, how do we measure distance and midpoint? And again, you don't have to print these notes out. You can just follow along, but they're there if you want to. All right, how do we measure distance and midpoint? First of all, distance is the length of a line segment between 2 points. The length of a line between 2 points, right? What's the distance from Miami to Tallahassee? It's if we connected the two with a straight line, which you can't draw on a straight line, but if we were on a map to connect the two with a straight line, you could measure the distance. Midpoint is the point halfway between the endpoints of a segment. So it's in the exact center, and it's equal distance from the midpoint to either of the other 2 endpoints. And then a segment bisector is any segment line or plane that intersects a segment at its midpoint. So it's a segment, a line, something that cuts through the middle of something else, right? Pythagorean Theorem. We're going to see how we get the distance formula from the Pythagorean Theorem. So remember when we're trying to find the length of the side of a right triangle, we use something called Pythagorean Theorem, and that is a squared plus b squared equals c squared. And A and B are 2 of the shorter legs of the triangle, and C is always the hypotenuse of our triangle. So what the heck does that have to do with the distance formula? That's what we're going to get into now. Distance on a number line. Distance can never be negative, right? Whether I go forward 5 feet or backwards 5 feet, I'm still going positive 5 feet. It's never going to be negative 5 feet. I'm still moving forward one direction or the other. So the distance between 2 points is the absolute value. Remember, absolute value is always positive. It's literally what absolute value does, is make any number positive. So it's the absolute value of the difference between their coordinates. Okay, so if I want to find the length of a line segment, it doesn't matter which order I subtract in. I can do this guy minus this guy, or this guy minus this guy. It doesn't matter, but I'm going to subtract, and then whatever that number is, I'm going to make sure it's positive, and that's my length. Okay, so symbols. If P has a coordinate of 3, and Q has a coordinate of 9, so here on our little number line, we're at 3 and 9. Then PQ equals what? It doesn't matter which direction I go. I can do, now this isn't a value, a size value. This is a location, this 3. And this 9 is a location. On a number line, where is point P located? Where is point Q located? Point P is located at the number 3, and Q is located at the number 9. So to find the distance between the two, I'm going to take their locations and subtract. And like I said, it doesn't matter which direction we do. So I have absolute value of 3 minus 9, which would be negative 6 inside absolute value bars, which would end up being positive 6. So our line segment has a length of 6. Or you could do it the other way and say 9 minus 3 in absolute value bars. 9 minus 3 is 6. And if we take the absolute value of 6, again, we still get 6. So either way, we end up with positive 6. It didn't matter which order I subtracted the endpoints in. Okay? And so that's the length of our line. 6 units between point 3 and 9. All right, distance on a coordinate plane. So now not only do we have side to side like a number line, now we're talking about the x and the y axis. We're going side to side and up and down. I'm out of space here. Okay, there we go. All right, so to find the distance between 2 points on a coordinate plane, x and y, you can form a right triangle. And then you can use this line. If we're finding the length of this guy, we're going to form a right triangle, and we're going to use this as the hypotenuse, right? So we're going to represent one endpoint, the x value of one endpoint. We're going to draw a line, a vertical line, and the y value, we're going to draw a side-to-side line, a horizontal line, right? So wherever these two lines intersect from this point and this point, they intersect here. Now we've got this right triangle with this 90-degree angle here. Okay, what the heck does that have to do with anything? Because all we're worried about right now, let me get a highlighter. I'm a visual learner. I know some of you guys are auditory learners, or you like to read what's in front of you. I am visual, so I use lots of colors and drawings, and that's how my brain works. All right, so we're finding the length of this guy, so we draw this guy, we draw this guy, and we see where they intersect. Where they intersect is not important, but how we come up with this next is. So here, we're going to use the Pythagorean Theorem to find AB, right? So if this is our right triangle, we take the length of this side plus the length of this side squared, sorry, plus the length of this side squared, and that's going to give us the length of this third side squared, right? So Pythagorean Theorem is A squared plus B squared equals C squared. And in this case, let me straighten this up. Here, I'll move up. In this case, A squared can be one of our side. Doesn't matter which side, right? Doesn't matter which is which. We're going to say our x axis, our x value here is. Well, we don't know what the length of this side is, right? So how do I figure out the length of this side? Well, we just talked about it. I just subtract. Length is distance, and to find the distance between two endpoints, I just subtract them, right? So I subtract one x value minus the other x value. So a squared here is actually one of my x values minus the other x value squared. And then, so that's this side here, plus b squared. B is this side of my triangle, this guy. So I don't know the length of b, but I know the distance between these 2 points on my y-axis is just one y value minus the other y value. So y minus y squared. And that's going to equal the length of this side of my triangle squared. And I don't know what the length of this side is, so I'm just going to call it AB, that side squared. Everyone following me? One side of my triangle is the difference in my x values. The other side of my triangle, the length, is the difference in my y values. And using Pythagorean Theorem, that's going to give me the length of this third side. Okay, so what do I do from here? I don't want to know the length of AB squared. I just want to know the length of AB, right? So how do I get rid of squared? How do I get rid of anything in math? I undo it. So to undo squared, I'm going to take the square root. And whatever I do on one side of my equal sign, I have to do that same thing to the other side, right? So once I take the square root of something squared, this little 2 and this square root symbol cancel each other out. So I'm left with the square root of x minus x squared plus y minus y squared equals the length of AB, right? So this formula is my distance formula to find the distance between any 2 points on a coordinate plane, right? It can't be a horizontal line. If it's a horizontal line, all we have to do is subtract these 2 points, right? If it's a vertical line, all we have to do is subtract the 2 points and we find the length. But when it's a diagonal line, when it's on a coordinate plane, it's got length and depth. I can't just subtract and be done with it. I have to use the distance formula, and this is how we come up with it. We kind of use the Pythagorean Theorem. So we're going to write that again in a second, but this guy right here is our distance formula. It's typed for you on the next page of notes, so if it's not all pretty and shiny like you like it, you're going to see it again. Okay, and then the midpoint formula. What the heck is the midpoint formula? We are going to have lots of practice on the second page, so don't worry about that. Midpoint formula on a number line. If M is the exact middle or the midpoint of line segment AB, here's line segment AB, here's point M, it's in the middle, then we can say that AM the length from here to here, is the exact same size as MB. They're equal. These two segments created by sticking this dot in the middle of AB, they're equal. This guy is congruent to this guy. Okay, and then we can say AM with the line over it is congruent to MB. Remember from the last lesson, if we're talking about numbers or size measurements, we don't put the line over top. This is representing an actual number, whatever the actual length of AM is. So we can say that this amount is equal to this amount. Or if we're just being more general, this line segment is congruent to this line segment. We don't have to know what the sizes of those are. We just know that they're congruent to each other. They're the same size. If line segment AB has endpoints at, and I'm going to give you, they had, I think, something else on your notes, but I'm going to give you actual numbers, 7 and 13. So down here I'm going to write a 7, and here I'm going to write a 13. Then the midpoint M of line segment AB is what? How do I figure it out? I am going to add these together, right? I'm not trying to figure out the length of this line. I'm trying to figure out the location of the center. So to figure out where the center is, not how far it is to the center, but where the center is, I'm going to add these together, 7 plus 13, and then just divide by 2. It's like I'm finding an average of the two, right? So 7 plus 13 is 20, and 20 divided by 2 is 10. So the location of my midpoint is 10. Does that make sense? Oh, sorry. Does that make sense? Yes, it does, because 10 is 3 units away from 7, and it's also 3 units away from 13. So that makes exact sense, like perfect sense, right? Sorry you couldn't see that there while I was talking. All right, next part. Midpoint formula on a coordinate plane. So that's easy on a number line. We're just going in one direction, right? I just add or subtract, divide by 2, I'm done. Well, it's more complicated when we're adding x and y values. We've got 2 numbers for a location of a point, not just one number. So you can find the midpoint of a segment on the coordinate plane by finding the average of the x coordinate and of the y coordinates of the endpoints. If PQ has endpoints at, we're going to give this 2, 8. I whited out here, and my whiteout stinks. 2, 8. And Q, we're going to say that it's at 10, 2. I think it works better to give actual numbers instead of just saying x1, y1, x2, y2, because that gets confusing. Like, we're not talking about theory. We're like saying, okay, if we actually had numbers, what do we do with them? So this point P right here is at 2, 8, and this point Q is at 10, 2. Then the midpoint of PQ is what? So how do I figure that out, right? So I know here, to get to P, if I went over 2, up 8, I know that this number is 2, and this number up here is 8. And to get to point Q, I had to go over 10, up 2, because the coordinate's 10, 2. So this is 10, and this is 2. So now I can kind of think of it as, all right, I'm finding the average of my x coordinates, and I'm finding the average of my y coordinates. So to figure out what this midpoint x is, I'm going to go add my 10 and my 2 together, 2 plus 10, and divide by 2. Just like I did up here on the number line, I'm just doing it on a coordinate plane now. So 2 plus 10 divided by 2 is what? 6. 10 plus 2 is 12, divided by 2 is 6. So my midpoint x value is 6. And then if I wanted to find the midpoint of my y coordinates, I'm going to add 2 and 8. Divide by 2. 2 and 8 is 10. Divided by 2, that's 5. So the midpoint between 2, 8 and 10, 2 is 6, 5. If you break it down to just the first numbers, 2 and 10, the exact center between 2 and 10 is 6. 6 is 4 units away from 2, and it's 4 units away from 10. The midpoint between 8 and 2 is 5. 5 is 3 units away from 8, and it's 3 units away from 2. It's the same distance, so that's our midpoint. If I wanted to just write it without a picture, I'm going to write x plus x divided by 2 and y plus y divided by 2. So here, my x's are 10 and 2 divided by 2. And my y's are, 2 and, what did I say, 2 and 8. And then once we simplify that, like I said, we get 6, 5. Hopefully that makes sense to you guys. Next page of notes. All right, some practice. I hold the paper sideways, but my phone isn't sideways, so I'm trying to hold it right. All right, use the number line to find the length of BC. Remember, when there's no line over top of it, we're looking for the actual size or the length of that line segment. So from B to C, right here, how do I figure out the length? Well, yes, the easiest thing is just to count, right? 1, 2. It's 2 units to get from B to C, we know that. But how do I do it using these numbers? Remember, the length on a number line is just the positive, whatever the positive value of the distance between here and here. So if I wanted to find that, I would say either -6 minus -4, and whatever that amount is, it's got to be positive, right? I have a double negative here, so that's going to turn into a plus. -6 plus 4 is -2. But distance can't be negative, so I'm just going to make it positive, +2. If I had gone the other way and said -4 minus -6, it'd be -4 plus 6, which would be +2 as well, right? Distance is the difference in two numbers. That's kind of easy to remember. When you're looking for the distance between two numbers, you find the difference between two numbers. Let's write that down. Distance equals difference. Now, when we have coordinate pairs, that gets a little more complicated, but in general, we're just subtracting, and it does not matter which order we subtract in, because whatever number we get, whether it's positive or negative, we're just going to make it positive, and that gives us the length or the distance between two endpoints. All right, AC. From point A to point C, we have -7 and -4. So I'm going to subtract -7 minus -4. Or let's just show that it's the same, so I could say -4 minus -7. Either one of those are going to give me the same answer. When I have a double negative, it becomes a plus. So here becomes a plus. -7 plus 4 is -3. -4 plus 7 is +3. And either way, once I take the absolute value, I get 3 units. So the distance between points A and C is 3 units. 1, 2, 3, we can see that. And the length of AC is 3 units. B, CF. So from C to F, that's a little bit longer. We're going from -4 on a number line to +5 on a number line. So I'm going to, I think we already know now for all of these examples, I could do it either way. It doesn't matter what order I subtract in. So I'm just going to pick one way. CF, C is -4, F is 5. -4 minus 5, we're finding the distance. Distance is always subtraction. Distance is difference. -4 minus 5 is -9. And the absolute value of -9 is +9. It's 9 units from C to F. We can count it. 1, 2, 3, 4, 5, 6, 7, 8, 9. Done. Okay, and then FB. F to B, right? Doesn't matter. It's this segment, so it doesn't matter which comes first. B is at -6, F is at 5. So I'm going to say -6 minus 5, which is -11. And then once I take the absolute value, it's +11. If we count it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It takes 11 units to get from B to F or F to B. Okay, example 2, distance formula on a coordinate plane. Again, it gives you your distance formula here. Distance formula is the square root of x minus x squared plus y minus y squared. I'm looking for my yellow highlighter. I think it fell. Let's try orange. I just wanted to highlight this so it stands out. Such an ugly highlighter color. Sorry if it's anybody's favorite. It's not my favorite. I like yellow. That one just stands out and looks dark. But that's our distance formula. So that's super important. It's okay if you don't know it yet. It's kind of a weird thing to memorize, but we're going to use it so much by the end of the year, you should pretty much know it. By the time you take your EOC, you will have to have that memorized. Okay, one little trick I'm going to tell you is that these little 2's and 1's here do not matter. Oops, zoom in. The 2's and the 1's do not matter. It does not matter which is the 2 and which is the 1. In fact, I don't even ever write that, okay? What does matter is that whichever ordered pair you start with, whatever ordered pair you get your X from first, you have to use that same ordered pair to start with that same Y first. Doesn't matter which one it is, but whatever one you start with, you have to start with its partner first over here. So what the heck do I mean about that? Let's do an example and I will show you. Move my camera back over. Okay, so here. Find the distance between E and F. So I'm going to start using colors because I'm a visual person. If you're auditory, you can still listen to me, and you help me out. Tell me what works best for auditory learners when you're listening to me so that I can work on that and do better delivering the message, through what I'm saying. But visually, I got to use these guys. So I'm going to make my X values purple, and I'm going to make my Y values orange. Okay, so if I'm doing the distance formula, D equals the square root of X minus X squared plus Y minus Y squared, right? It does not matter which order I do this in. So whether I use -4 minus 3, or I can use 3 minus -4, it doesn't matter. But whatever order I use my X's in, I have to use the same order for my Y's. So since I started with -4 first in this part, I have to start with its partner first in the second part. Okay, so I've got a 1 and a -1. So X minus X squared plus Y minus Y squared in the same order. Now I can start simplifying. So square root of -4 minus 3 is -7 squared. 1 minus -1 actually becomes 1 plus 1, which is 2 squared. So when I start simplifying, I'm going to do it up here. Square root of -7 squared is 49 plus 2 squared is 4. 49 plus 4 is 53. Okay, next thing I'm going to tell you is this is an exact answer. If I actually take the square root of 53, I'll show you on the calculator, on this XA calculator, which is the type of calculator you're going to use for your benchmarks in EOC this year. So if you'd like to purchase them, they are less than $9 at either Target or Walmart or Amazon, but Target and Walmart always have them. So if I'm going to type this in, square root of 53, I'm going to hit 53 and then hit my square root button right here. It gives me this long decimal, right? And actually, that decimal keeps on going. It just can't keep going in this calculator, so they stopped it here at this last digit, this 9. Okay, so if I were going to write 7.2 or 7.28 or 7.3, none of those would be accurate because they're not representing all this. They would just be me estimating, right? Or rounding, me rounding. I don't want that. I want an exact answer. So anytime you get a radical and when you actually take the square root, it gives you that long decimal, that's not accurate. The best way to represent that number is to keep the radical. So I'm going to leave it just like this. Now, if we're talking about the size of something in math, right? Like the size of that piece of wood, the length of that piece of wood is square root of 53. I don't know what that is, right? So then it would be helpful to kind of know, okay, 7.28. So that's about 7.3 feet or inches or whatever. That would help me to round it. But in general, when I'm just solving, keep the radical. All right, next one. B, -5, 6, and 8, -4. I'm going to color code this just to set it up. I should have just done that at the same time. All right, so when I write it, square root of distance between E and F is x minus x squared plus y minus y squared. My x's are in purple, so -5 and 8, or you can do 8 minus -5, that's fine. But whatever order you do purple in, you gotta do orange, your y values, in the same order. Since I started with -5, I gotta start with 6. And I'm gonna have 6 minus 4. So now I can start simplifying. Square root of -5 minus 8 is -13 squared. 6 minus 4 is 2 squared. -13 squared, -13 times -13 is +169. And 2 squared is 4. And when I add those together, 169 and 4 is 173. I don't know why I wrote that line so long. So it's the square root of 173. Now, if I wanted to know, if that was an actual length and it was representing a building or something like that, and I wanted a better idea of the size, I could use my calculator, 173 square root, and it's about 13 point blah, 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 blah. So feet, inches, whatever, it's a little over 13. But here, I'm just wanting the exact number. So I'm gonna stick with square root of 173. Okay, and then lastly, square root of x minus x squared plus y minus y squared. My x's are always the first number in each coordinate. My y's are always the second number in each coordinate. So 4 minus -3 squared plus 3 minus -7. And again, I know I sound like a broken record, but it doesn't matter. We could have said -3 minus 4 and -7 minus 3. We're going to get the same answer either way. Order doesn't matter as long as whatever order you do the x's in, you have to do the y's in the same order. You have to write them in the same order. Okay, now we simplify. Square root, 4 minus -3 is actually 4 plus 3, which is 7. 3 minus -7 is actually 3 plus 7, which is 10. 7 squared is 49. 10 squared is 100. Now be careful that when you're solving, it's like kind of tedious to keep writing this little square root thing over and over and over. So sometimes we get lazy, and as we're solving, we just stop writing it and we just start doing the numbers, and we think, okay, I'll remember at the very end to go back and write the radical. I promise you, you might remember to do that a lot of the time, but there will come a time when you're gonna forget. You're working so fast, you're doing all this math, you're gonna start writing the answers, so you'll say 49, okay, that's 149, done, and you're gonna move on. And it's not 149, it's the square root of 149. You have to remember to keep that radical sign. And I kind of wrote over my midpoint formula here, but the answer to this C part is the square root of 149. If we were gonna find it in a calculator, 149, oh, there's the bell, I'm here at school. You guys feel like you're here? Hit square root, it's about 12 point blah, 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 blah. 12, a little over 12 something units. Okay, and then lastly, we have our examples of midpoint formula. Find the coordinate of M, the midpoint of GH for this information right here. So again, I'm gonna use purple for my X's and orange for my Y's. So when I write the midpoint formula, I'm gonna do X plus X divided by 2 and Y plus Y divided by 2. So if I add my X's together, I have 8 and -14. And if I add my Y's together, I have -6 and +12. Okay, so then I just start simplifying. 8 plus negative 14 is actually 8 minus 14, which is negative 6. And then when I subtract my y's, add my y's, I misspoke, you add together for the midpoint formula. You're just finding an average between your x's, average between your y's. So when I find the average of my endpoints, the y value, negative 6 plus 12 is positive 6. And then of course I have to divide both of those by 2. So I end up with negative 3 comma positive 3. That's my midpoint. Oh, I don't know why I just wrote that. I saw the M. So my midpoint, negative 3, positive 3. Okay, same thing here. I'm not going to color code this. I'm just going to write it, but you guys can visually see. If you're a visual learner like me, you can see where those numbers came from. Okay, so here, A is 512, B is negative 48. I'm going to average my x values. So 5 plus negative 4 divided by 2. And I'm going to average my y values, the second number in each coordinate pair. So 12 plus 8 divided by 2. 5 plus negative 4 is the same thing as 5 minus 4, which is just 1 divided by 2. And then 12 plus 8 is 20, and 20 divided by 2 is 10. So my midpoint between A and B here is 1/2 comma 10. And then lastly, I want to find the midpoint between C and D. So I'm going to add my x values together, divide by 2. Oh, there's the tardy bell. Seriously, feels like you guys are here. Negative 8 plus 5 divided by 2. Negative 2 plus 1 divided by 2. Negative 8 plus 5 is negative 3. So I have negative 3 divided by 2. And then negative 2 plus 1 is negative 1 divided by 2. Now I could change it to a decimal if I wanted to keep going, right? Or I could simplify improper fractions. I'm a big believer in if you're given fractions or when you're solving, if you get a fraction, don't change it to a decimal. Just stop. That's an extra step. Just leave it. Definitely if the problem originally gives you fractions, your answer needs to stay in fraction form. If you're originally given decimals, your answer stays in the decimal. We weren't given either one originally here. I'm just going to leave it in fraction form here. But I know that this is negative 1.5, right? Negative 3 over 2 is the same as 1 and 1 over 2. So negative 3/2, negative 1/2. All right, example 4. Find the coordinates of the missing endpoint. So here we are doing the exact same thing. But instead of having the 2 endpoints and not knowing the middle, if I had a line, normally I know the 2 endpoints and I have to find where the middle is. Here, they're going to tell me where the middle is, tell me where one of the endpoints is, and I have to find the other endpoint. But seriously, it's doing the exact same math. Okay, find the coordinates of D if E is the midpoint of DF. So I know line DF, D and F are my endpoints, and then the midpoint it tells me is E, DEF, right? Okay, so it tells me that the midpoint is at negative 6, 4. That's the last one, I promise. And it tells me that F, one of the endpoints, is at negative 5, 3. Okay, so like normally, I'm going to add my x's together, divide by 2 to get this guy. I'm going to add my y's together, divide by 2 to get this guy. I'm still going to do the same thing. It's just a little more complicated, right? So I'm going to break it down in my x and my y values. So for my x values, I don't know right now what they are for D. So I'm just going to say it's x and y, okay? So to find my x value, again, I'm going to add my 2 endpoints together, divide by 2. That gives me the midpoint. So I'm going to add x plus negative 5, divide by 2, and that gives me my midpoint, which is negative 6. And I'm just going to keep solving for that, right? So to solve this, to get x alone, I first want to get rid of the denominator. So to get rid of divided by 2, I'm going to do the opposite, and I'm going to multiply both sides of my equal sign by 2. So when I do that, here, I'll put a 2 here, and I'll put a 2 here. These 2's cancel. So I'll have x plus -5, which is x minus 5, equals -6 times 2 is -12. And then to get x alone, I'm going to add 5 on both sides of my equal sign. And these are going to go away. X equals -12 plus 5 is -7. So the x value of my endpoint here is -7. Now I want to find the y value of my endpoint D. Sorry, this is moving around. Nicked my finger. By the way, if you guys see my fingers on here and make fun of it, I have been told everything in the world. I have dry cuticles and short fat fingers, and you know what? I can still write with them, I can still use them, so I'm okay with that. But yes, I'm aware. All right, so y value, okay. So we're gonna add our two y values, endpoint y values together, divide by 2, get our midpoint. So y plus 3 divided by 2, and then our midpoint, it tells us, is 4. So I'm going to start simplifying. So to get rid of that divided by 2, I'm going to multiply by 2. And I got to do the same thing on this side. These 2's cancel. Sorry, this is looking messy. So I'm left with what's inside here. Y plus 3 equals 4 times 2 is 8. And then I need to subtract 3 on both sides of my equal sign. And that gives me y equals 5. So it told me the midpoint. That's not what I was looking for here. I'm looking for D, which is one of my endpoints. And I know my x value is 7 and my y value is 5. So I know D is at -7, 5. I think I said +7, it's -7. -7, 5. That's how we find our endpoint. So we're going to do the same thing, kind of more quickly here for these two. And actually, I'm going to pull out some more paper because it doesn't give me very much room on your notes here. So I'm going to use additional. Sorry if that's looking crooked to you guys. All right, so for E, it says find the missing endpoint of DE if P is the midpoint. So to get kind of a visual here, I have my two endpoints, D and E, and P is right in the middle. So it's going to give me P for both of these problems. It's going to tell me what the midpoint is. It's not going to tell me what one of the two endpoints are. That's what I'm looking for using the midpoint formula. Okay, so here, E, one of my endpoints, is -8, 6, and the midpoint is -5, 10. So I'm going to start with just looking at my x values, and I'm missing, I have E and P, I'm missing D, right? So here, if I think of it two different ways, first of all, if I'm thinking about finding the midpoint of my x values, and I have E, P, I can say, sorry, keep it the same, D, E, P. E, my x value is -8. P, my x value is -5. So I'm looking for the x value for D. So to find that, midpoint formula, add your x's together, divide by 2, right? In this case, I'm going to add x plus -8, divide by 2, and then I know the answer is my midpoint, which is -5. So then to solve for x, I first have to get rid of this denominator, this divided by 2. So I'm going to multiply everything by 2, and those 2's will cancel out, and I have to multiply by 2 here. So I'm left with x plus -8, which is really x minus 8, and -5 times 2 is -10. And I hope you guys already know this, but don't feel bad if you need to pause the video, if you need to catch up, if you're confused, or go back and watch it, whatever. That's the benefit, the positive side of having videos here instead of live. right? Your questions, you can go back and rewatch the video. If I messed up, or sometimes even I misspeak in these, I do a bunch of these videos. If you ever think, she just said 3, but it's supposed to be -3, let me know, okay? It doesn't happen that often, but I'm human. It can happen. All right, so x minus 8 divided by 2 equals -5. We multiply both sides by 2. Now we have x minus 8 equals -10, and we're going to add 8. X equals -2. So the x value of my endpoint is -2, and now I want to find the y value of my endpoint, so I'm going to do it the same way. Now I'm looking at the y values. So if I have my line and I have D, P, E, and I don't know what my y value is for my D point, I know the y value for P is 10 and the y value for E is 6. Okay, so I'm going to add the two together, divide by 2 to get the middle. Y plus 6 divided by 2 is going to equal 10. I'm going to multiply by 2 here for those to cancel out. I've got to multiply by 2 over here. This is why I had to have extra paper. It takes more room. Y plus 6 equals 20. Subtract 6, and I get y equals 14. Okay, so for my end point here, my answer was, my x value was -2. My y value was 14, so -2, 14. Does that make sense for this problem? If P is -5, 10, and E is -8, 6. Let's look. -2, -5, -8. Am I going up the same amount? Yeah, I subtracted 3, subtracted 3. Okay, looking at my y values, 14, 10, 6. 14 to 10, I subtracted 4. 10 to 6, I subtracted 4. So here I'm going down 3. Here I'm going down 4. I'm going the same amount. So P is in the exact center of D and E. Makes sense. All right, and then a little more quickly, we're done. Last problem here. B, P, D. P is our midpoint. D is one of our endpoints. D, P, E. We're trying to figure out where point E is. We don't know where this point is. It's x, y. D is, P, the midpoint here, is -1, 3. And D, the known endpoint, is 5, 6. Okay, so using that same kind of intuition or thinking it through, like kind of common sense that we did right here at the end just now, if I'm looking at these and I go from D to P, 5 to -1 for my x value, what did I do to get from 5 to -1? I subtracted 6, right? So if P is in the middle, that means whatever I'm doing to get from D to P, I have to do the same thing to get from P to E, right? So if I'm subtracting 6 here, wouldn't I also have to subtract 6 to get from -1 to x? So that would be -7. Sorry, I'm trying to write -6. -1 minus 6 would be -7 here. And then for our y values, same thing. What did I do to get from 6 to 3? I subtracted 3. So to get from 3 to y, if I subtracted 3 again, I'd get 0. Right? So using just kind of thinking it through here, whatever I did to get from here to here has to be the same as here to here, since P is the midpoint. I should end up with a point at -7, 0. But I'm going to use the whole midpoint formula intuition. Logic. Another way to write this for the midpoint is I'm going to add for everything, I'm going to add my x's together, divide by 2 to get my midpoint. So I'm going to add 5 plus x divided by 2, and I know the answer is -1. And then for my y value, same thing. I'm going to add 6 plus y divided by 2, and the answer is 3. So that's my coordinate pair here. I just have to simplify everything, right? So here, when I'm solving for x, I have to multiply both sides of my equal sign by 2. So I'm going to end up with 5 plus x equals negative 2. Here for the y, same thing. I'm going to multiply both sides by 2. So I'll get 6 plus y equals 6. Okay, over here, so I'm just simplifying my coordinate pair. Over here, I am going to subtract 5 from both sides of my equal sign to get x alone. So I'll get x equals negative 2 minus 5 is negative 7. And over here, I have to subtract 6 from both sides. So I'll get y equals 6 minus 6 is 0. So I don't have to write x equals negative 7. I can just write negative 7. And here I don't have to write y equals 0. I can just write 0. So my endpoint is negative 7 comma 0. And that's kind of what we kind of guesstimated it was going to be, right? So there's a few different ways to think this through, but our midpoint formula is x values, add them together, divided by 2. That gives you your midpoint. Y values, add them together, divided by 2. That gives you your midpoint. And in this example, we had the midpoint, but we were missing one of the endpoints. Okay? Let me know if you have any questions.